Well, friends, today I'll talk to you three-dimensional geometry. Earlier, I talked to you vectors, and connected to the vectors, I want to make three-dimensional simple. You get 3, 4 questions in NDA based on the three-dimensional. I take from the clue from vectors how vector three-dimensional vector go to three-dimensional geometry. Very simple. I take the question, very simple question they are asked in NDA. Hopefully you will able to do. Let me start from the basic today, and tomorrow I'll take up the further one higher, and in 3, 4 days I'll finish in the three-dimensional. So my first part is that we go into vectors. I'll use the vectors concepts. Here three dimensions. Three dimensions means here we got x-axis, and this is y-axis and z-axis. This is the origin. If you put this side, this is O dash, is negative side of this. If you do this one, this is the negative side of the y, and you this thing is z dash is the one. When we have got one line and we have another line, there are 4 points, and we divide another point, there are 8 points. There are we have got eight boxes like this. When you divide this one and divide 1, 2, 3, 4, when you just draw one line, another line, these are the 4 1. When this is, they are called quadrants. Quadrants. Now, you divide another in these 1/4 into another one, another line, they become 8. This is octant, we call it octant. This is the octant here. One octant here, when x positive, y positive, and z positive. This is one octant here. So this is octant. Like this octant, one side, other side x positive and z positive and y negative. There are 4 possible. You have got all plus. This one, this is plus and this is minus. This is plus, this is minus, this is minus, plus this. Here is minus 1. We have got 8 types, or we can do this one. Here, taking the 2 positive, 1 negative, 2 negative here, this is minus minus, this is equal to minus plus minus, and lastly minus minus minus. 8 possible octant are there. First of all, there are 3 lines, and they divide the whole space into 8 parts, and these 8 parts are known as octant. Positive octant is that which have got x-axis, y-axis, z-axis, all positive. This is which I have drawn here in the block. This is a octant with a positive x-axis and y-axis. So first of all, the space has been divided into the 8 parts, and they are known as octant. Well, friend, I just draw here. This is x and y. This is z. Here, x. This is called xy plane. The plane containing xy plane. This is called yz plane, and this is called zx plane. They are plane. They are coordinate planes. They are coordinate planes. These are coordinate axes. These are coordinate axes, and these are coordinate planes. Xy, yz, zx. They are coordinate planes. They are planes, and x-axis, y-axis, and z-axis. They are known as coordinate axes. Well, after this, we have the point xyz point here. So there is a one x-axis, y-axis here. Overlap. I take x-axis, y-axis, z. I told in vectors. Suppose there is a point P here, and this is the position vector of this point. This is the position vector of point P. So what is the position vector? This OP vector I said is equal to x into I plus my y into j plus z into k. Friend, x is a coordinate projection. This is x is the component here. Along the y-axis, when you draw it, this is drawing here. Suppose I draw from here to here is z, then going to y, and this is equal to x, y, and z. They are called x component, y component, and z component. These are called xy component. This is it. X is the projection of this on this. This is x, y, z. This is the component. This is one. X, y, z, the component, component, component. Look, friend, this x, y, z, when I draw the projection of this, what is the z? Z is the distance of point P from xy plane. XY, this is what is the z coordinate? This is z, I said. What is x here? This x is the distance from what plane? Or the point P from what plane is equal to, when is x? This is equal to yz plane. Y is the distance of the point P from the, this is xz plane. Sometimes this question is asked in India. Simple question. They ask from here. He says, what is distance of this point point P from xy plane? What is distance of this point from xy plane? So answer is 3. 3 is the answer. 3. What is the distance of this point from yz plane? Yz plane x coordinate 2. What is the distance of this point from the xz plane? It means 1. That is one part. So first of all, this point, how to find the distance of a point from the given coordinate plane. Coordinate plane से हमने distance निकालना हो तो कैसे निकालेंगे? सवाल मेरा जैसे कि 4, 1, 7. What is the distance of this point from the xy plane? It means 7. What is the distance from the xz plane? It means y coordinate. What is the distance of this point from yz plane? Is equal to 4. हमें किसी पॉइंट का डिस्टेंस निकालना हो, गिवन पॉइंट का किसी कोऑर्डिनेट प्लेन से डिस्टेंस निकालना हो तो इस प्रकार के हमारे कोऑर्डिनेट्स होते हैं। आइए दोस्तों, मान लो ये हमारा ये लाइन यहाँ से हमारा कंपोनेंट ये वाला OP वेक्टर है और ये वेक्टर xi प्लस में yj प्लस zk है और मैंने कहा x y z दे आर नोन एज कंपोनेंट्स। ओके, इनको कंपोनेंट्स की बजाय मैं इनको डायरेक्शन रेशियो भी कह सकता हूँ। दे आर द डायरेक्शन रेशियो, दे गिव द डायरेक्शन ऑफ द लाइन OP लाइन का मुझे डायरेक्शन रेशियो क्या है x y z। They determine the direction of the line. Direction of the line is x, y, z. Okay. If I make this angle alpha here, and this is called beta, and this is gamma. Alpha, beta, gamma. They are known as direction angles. They are known as direction angles. They make the determine the directions of a line of the vector or line OP. OP is the one to. This is the direction of the direction angle of the one to go for. Direction. OP की directions हैं. This is the OP direction here. Well, friend, when I take the direction, this side is equal to, when I take it, this is equal to x. And this I take, suppose this OP, magnitude of OP is equal to, let me take r, x square plus y square plus z square under the root. This is OP. Let me, this is equal to r. Look friend, x upon r is equal to cos alpha, and similarly y upon r is equal to cos beta, and look at the cos gamma is equal to z upon r. Alpha, beta are the direction angles. Then we can find cos alpha, cos beta and cos gamma. Look here, if I square them, if cos square alpha plus cos square beta plus cos square gamma, what is equal to? X square plus y square plus z square divided by r square. And what is x square plus y square is equal to this is equal to r square. R square divided by r square is equal to 1. So friend, these are called direction cosines. This cos alpha, cos beta, cos gamma, they are called direction cosines. They are called direction cosines. These cosines, they determine the direction cosines, they determine the direction of the line. Cos alpha, cos beta, cos gamma, there. And if I name them, I will usually name them L, M or N. Then we say the L square plus M square plus N square is equal to 1. The sum of the squares of direction cosine is equal to 1. Sum of the squares of direction cosine is equal to 1. Means cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square gamma is equal to 1. So 1 cancel. Sine square alpha plus sine square beta plus sine square gamma is equal to 2. Another equation from here. Sine square alpha, well, if I put it to 1 plus cos 2 alpha divided by 2, 1 cos square alpha is equal to 1, cos square beta is equal to 1 plus cos 2 beta divided by 2, 1 plus cos 2 gamma divided by 2 is equal to 1. So I just cos square, I convert into the double angle, this is equal to 1, cos square alpha plus cos square beta. So one equation, cos square alpha, so I have 1 plus cos 2 alpha plus 1 plus cos 2 beta plus 1 plus cos 2 gamma is equal to 2. So another equation, 2 alpha plus cos 2 beta plus 2 gamma is equal to 1, 2 cos is equal to minus 1. This is minus 1 here. So friends, first equation is this. What I did now is the relation which is called directional cosines. The alpha, beta, gamma are the angles a line makes with x-axis, y-axis and z-axis. And these angles, there is a relationship. This is equal to cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos square alpha plus cos square beta plus cos square. Remember, sum of the square of directional cosines is equal to 1. And when a line makes an angle alpha, beta, gamma with the x-axis, y-axis, z-axis, then what is the relationship? The sum of the square of this is equal to 1. Let me do one question here. Suppose a line makes a 60-degree angle with x-axis and z-axis. So what angle it makes with the y-axis? What is the angle it makes with the y-axis? One question. Well, the alpha is equal to 60 and gamma is 60. So cos square 60 plus my cos square beta plus cos square 60 is equal to 1. 1 by 2, 1 by 4 here. Cos 60 is this. Cos square beta plus 1 by 4 is equal to 1. Cos square beta is equal to half, and therefore cos beta is equal to 1 over under root 2, and therefore beta is equal to 45. This is the question. Here is the question. A line is equally inclined with a positive direction of x-axis, y-axis, all the axes. Then what angle it makes? What is the angle it makes with them? Answer is cos square alpha. The another is also cos square alpha. Another is cos square alpha is equal to 1. 3 cos square alpha is equal to 1. Cos square alpha is equal to 1 over 3. And cos alpha is equal to 1 over 3 under root. That's here. And alpha is equal to cos inverse 1 over under root 3. This is the answer to it. So we have the type question like this. When angle 1 alpha beta given find this, have the relation this. And we have done this type of question. I'll be doing one more question on that. We find out the direction cosines of my next question is what is the direction cosine of x-axis and what is direction cosine of the y-axis? Direction cosines of x-axis. Direction cosine of x. Friends, x-axis makes angle 0 with it, 90 with the y-axis, 90 with the z-axis. So direction cosines are cos 0, which is 1, cos 90 0, and cos 90 0. So therefore, it's equal to 1 0 0. Well, friend, here it is. What is direction cosines of yx is equal to 0, 1, 0. What is direction cosines of zx is equal to what? 0, 0, 1. This is one. I said when I got a point x, y, z here in the space, this is one point here, O is the one, this is the r is equal to x square plus y square plus z square under root, this is 1. And I said if this is cos alpha, I said is equal to x upon r, and cos beta, which I call it L, this is called m, and y upon r, and n is equal to cos gamma z upon r. They are called direction cosines. They are direction cosines here. L, M, N, direction cosine. This is proportional to x. This is proportional to y. This is proportional to z. Any numbers, any one which are proportional to direction cosines, they are known as direction ratios. Direction ratios are proportional to direction cosines. Direction cosines are there they are unique of a line. When a line is given, the direction cosines are very, very unique. But direction ratios, I said, L is suppose proportional to A, and the M is directional proportional to B, and N is proportional to C. So L, M, N I am denoting with the direction cosines. So L is equal to K into A, and M is equal to K into B, and N is equal to K into C. I know L square plus M square plus N square is equal to 1. Therefore, K square A square, K square B square is equal to 1. C square, K square common, 1 over under root A square plus B square plus C square plus minus is equal to K. K is equal to this. When I get the K, I can find out what is the direction when A is given to me, B is given to me, C is given. When direction ratios are given to me of a line, direction ratio ABC given to me, then how to find direction cosines? That is the question. Direction cosines are like this. This is equal to plus minus A upon this under root A square plus B square plus C square. And the another one plus minus B upon under root A square plus B square plus C square plus minus C upon under root A square plus B square plus C square. This is it. When ABC are given direction ratio to you, then how to find the direction cosines? Direction cosines can be found. Let us look at this now. I got 2, 1, 4. They are direction ratio. Then what is direction cosines of the line? It's a 2 upon 4 plus 1 plus 16 under root plus minus 1 upon this is equal to 21 plus minus and 4 upon under root 21. This is this. Okay, if I got the direction ratio is 4 to 8. 4 to 8. I just multiply by 2. What is direction cosines? Direction cosines is 4 upon 16 plus 4 plus 64 under the root plus minus 2 upon this is equal to 20, this is equal to 84 plus minus this is equal to 8 upon 84 plus minus. I just take the 84 here, this is equal to plus minus 4, 2 into 21 and plus minus 2 upon 221 plus minus 8 upon 2 into 21. Dear friend, when 2 cancel, this comes the same. My conclusion is direction ratio of line can be many. It can be infinite. One can be 2, 1, 4, so another can be 6 and 3 and 12. Okay, it can be 16, 8 into 32. The ratio, as I said, the ratio can be of a line, can be infinite. Direction ratio of a line can be infinite, but when you find direction cosine, they are unique. There is one. Cos alpha, cos beta, cos gamma is one. That is very, very simple. Direction ratio of a line are infinite. They are, as the name suggests, they are direction ratios. For direction cosine, that is only one. Now, I just did in vectors. There is a one point known x1, y1, z1, and another point is equal to q, x2, y2, z2. These one. How to represent PQ? What is PQ vector is equal to? X2 minus x1 into I, y2 minus y1 into j, plus z2 minus z1 into k. PQ is this. X2 minus x1, y2 minus y1, and z2 minus 1. As I suggested, these are the direction ratios. Direction ratio. What is direction ratio? What is direction ratio of PQ? The answer is x2 minus x1, y2 minus y1, and z2 minus z1. That's it. Direction ratio. This is the direction ratio of the PQ. You can find direction ratio for direction cosine. You can easily find first PQ is a line here. You find this one, then this is vector. So what is direction ratio of line joining line 3, 2, 1 and 7, 4, 3. So direction ratios are it is equal to 7 minus 3 and 4 minus 2 and 3 minus 1. The answer is equal to 4, 2 and 2. So we learned how when 2 points are given to us, what are the direction ratios and how we can find direction cosines of the line that I want to carry. This is the direction ratio of the line joining 2 points. When 2 points are given, here one point is minus 1, 7, 3, another point q is 2, 5, 8. Then what is direction ratio of the line PQ is equal to 2 minus 1 plus 1, 5 minus 7, 8 minus 3. Answer is 3 minus 2 and 5. That is direction ratios. Here we have learned how to find direction ratio of line joining the 2 points. Well, friend, before I go to next topic tomorrow, I just want to finish with the one point that is when we have got one point A here, x1, y1 and z1. Another point is B is x2, y2, z2. So how to find distance between the 2 points? Well, a distance formula. First is distance formula. I want to do distance formula. x2 minus x1 into I plus y2 minus y1 into j and z. This is a vector. The distance between them is the magnitude of this. Magnitude is a distance between them, AB. What we learned from this square, x2 minus x1 square plus y2 minus y1 square and z2. Distance between 2 points like this. We find the distance formula. This square plus this minus this whole square, this minus this. This is how we find the distance formula. Well, friend, another formula that we have, A is equal to x1, y1, z1 and B is another point x2, y2, z2. This divide in the ratio n is to n. But then what is the coordinates of this point? Well, this is the position vector if I take from this one. Another point is this position vector of this. The position vector of this point C is equal to the point position vector of this C OC is equal to this is equal to m into position vector of this position vector suppose B and this is position vector A. I said m into B plus n into a divided by m plus n. Well, this is the found. Well, this is the question vector of the point C, which divide this in the ratio. Well, I am writing now. M question vector of B is equal to x2 into I plus y2 into my j plus my z2 into my k plus n into my x1 into I plus my y1 into j plus my z1 into my k divided by m plus n. Okay, I am writing here m into my x2 plus my n into my x1 into my I plus my m into my y2 plus n into y1, okay, into my j plus m into my z2 plus n into z1 into my k divided by m plus n divided by m plus n divided by m plus n. So this was OC. Therefore, C point is equal to, what is C point is m into x2 plus n into x1 divided by m plus n, and similarly m into y2 plus n into y1 divided by m plus n, m into z2 plus n into z1 divided by m plus n. And if it is a middle point, friends, if it is a middle point, then this will be x1 plus x2 divided by this. Well, here we go. This is the we found. This is called section formula. This is called section formula. Section formula is, there is a 1 A and B is a 1. This is x1, y1, z1, and this is x2, y2, z2. A point C divided into m is to n. Then what is C coordinate is equal to this m into x2 plus n into x1, m into this is 1. If this point is external, if it is external, this is internal. If it is external, the change will be minus sign here, minus sign. If this C point goes outside, then the C point will have, it will divide externally this minus x1 divided by m minus n. M into y2 minus n into y1 divided by, the change only will be this one, divided by m minus this. There is one point. Suppose we have got a question, we have a is equal to abc. This point is x1, y1 and z1. This point is x2, x2, y2, z2, x3, y3, z3. What is the centroid? Centroid. We have done this is x1, I did in the vectors, divided by 3, and y1 plus y2 and z1, z2, y3. This is the midpoint is x2 y plus y3 divided 2 is to 1, and we'll find the centroid is equal to x1, x2, x3 like this. So first part I did the introduction, what is the direction ratio, how to find direction ratio to direction cosine, what is the relation, sum of the scale of direction cosine is equal to 1. When alpha beta is given, you can find gamma, what distance of a point from xy plane, from difference. This we have discussed the basics. Okay, tomorrow I will be talking to further one, the plane. So we'll talk with the plane, we will discuss later on to go, and hopefully you will enjoy and do the question. Thank you.